Right, good morning. We are in chapter 8, second section. The first section was about relations. Relations are just pair of numbers listed in parentheses, okay? And some of them are only 10 list of pairs. Some of them can be infinite many, you can't count. Relations just couple a number into another one. Now, today we are going to describe functions and see the relation between functions and relations, okay? So a function is actually a relation. Those things you seen last week can be functions. They're actually, some of them are functions, but you need just one more extra conditional relations. What is that extra condition? Here is in words how we describe this. Each element x, the first number in the parentheses, in the couple, first number, should always be matched into exactly one y value in the range. Okay. One number on the first component can only show up once and can only go to one and exactly one number on the second component. What do I mean by this? It's hard to visualize this by words, but let's find it out in the examples. 3 examples given here. So these are x values. And here is what couplings do we have. I'm going to start with C. I see 1 going to 4. I see 2 is going to 4. I see 3 going to 4. Let's check if this statement is true for these couplings. For each element x, this is x, this is x, and this is x. Do you see exactly one y value in the range? Do you see, for this is element 1. Do you see exactly one value for 1? Yeah, I see 1. 1 going to 4. This I see on 2 is going only to 4. 3 is going only to 4. Everybody is going to only one destination on the right side. So this one fits into this description. We call it function. This thing is a function. Now switch to this side, please. Now you will see clearly what's going on wrong. 1 is going to 3 first. I'm writing this. 1 is going to 3. And then same 1, but with another arrow going to 4. 2 is going to -1. And 3 is going to -2. So this is your relation in part A. Do you see each element x going to only one destination, one match on the y? Look, 2 is going to one match, 3 going into one match, but 1 is same one going to 2 locations, 3 and 4. So if there is a repetition in one of the couples, first term repeated, then this is not a function. 1 is going to 3 and same one is decided to go to another way, impossible. It's not a function. It's a relation, but not a function. Okay? Alright, here is a real life example of functions. Functions are like buses. Think functions are like bus routes. Now, x's are your passengers. You have passenger 1, passenger 2, passenger 3. 3 different passengers. Y's are their destinations. Like passenger 1 leaves the bus at bus stop 3 or city 3. And that's city 4, city -1, city -2. There are 4 cities here. Now here is the situation. Can a passenger, same passenger 1, whoever name this passenger has, can this guy go to 2 different cities with a single bus? No, you need to leave the bus. You can't take that bus again. You're out. When you're arriving at city 3, you can't go to city 4 anymore by the same bus. Okay? So this is impossible. Impossible. It cannot be a bus route. It cannot be a function. Okay? Because this is kind of confused sometimes. After a couple weeks, you forget what was the real definition. We can't split up two ways or two functions going the same way. No. Think buses, passenger, and routes and destinations. Okay? Now, how about here? Can 3 passengers go to the same city or same address? Can you go? Yeah. They are living on the same street maybe. Okay? In the same house maybe. So of course they can leave the bus in the same stop. So this is function. How about this one? Is everything okay with this one? Person 1 going to address 4. Person 2 going to address -1. Person 3 is going to separate address. So this is a function. Okay? Is it clear? Function definition? Again, can't happen unless you split two ways. Top half going into one city, bottom half going into another one, which is not gonna happen, right? Alright. There are 2 questions related to what we just learned. So in our homework, let's do the first one. True or false? Is this a function or not? How many people say it's a function? How many? Raise hand. Maybe you're right. No. Nobody? Okay. This is not a function because a single person, even the first attempt, going into 2 different cities, addresses, not possible in a function. It's a relation, but another function. Alright, again, don't go with trial and error. Don't, if this one doesn't work, don't try the another one, okay? Know why. Okay, in the second expression, you don't have arrows. You don't have arrows, but you can make your own arrows if you wish. Look, I see 3 going to where? 1/2. Okay, and then I see the same 3. You cannot repeat it. You're not allowed to repeat in this diagram. You take the same 3 where? -1.9. You don't have to check the rest. What is the verdict? What's the conclusion? Not a function. First one failed us. You don't have to check the remaining ones. Okay? Well, the others were fine though. These are all unique addresses going in each single person going to a unique address, but still the first one is violating the rule. Not a function here. Alright, so far so good. Any questions? There is a second test. If you are given graph of the functions as dots or as connected curves, you can do a vertical line test to check whether the given relation belongs to a function or not. The graph belongs to a function or not. How? You first, if this picture was not given, you first plot each dot. 1, 3 is here. 1, 4 is there. 2 minus 1 is here. 3 minus 2 is there. Plot them and go through those dots with vertical lines. You draw these lines on your own. You're free to make these laws. Draw them. You pick 4, 3. And what do you observe right here? There is a single line crossing 2 or more points. 2 points exactly here. This is a violation of being a function. Why? Because a single passenger 1 is going to 2 different destinations. Look, 1 is going to 3 with this dot, and 1 is going to 4 with the same dot. Look, 1 going to 3, 1 going to 4. This is called vertical line test, not function. This second one is a function. There are 3 dots. I plot them, and each dot has its own separate vertical line. Every passenger going to unique destination. 2 is going to -1, 3 is going to 2. Everybody is fine. Okay? Alright? Now, what is the situation here? We don't have separated dots here. You have cumulative millions and billions of dots forming an ellipse, this shape. How do I test whether this is a function, belongs to a function or not? Easy. You just take, again, any vertical lines, as many as you wish. You can do this all day if you want. But just one bad sample is enough. One sample showing that, what is this showing? Make this bigger. What does this show? I'm crossing this 2 points. Maybe this one is like 2, 1, and this is 2, negative 1. Same 2 x coordinate going to 2 separate locations. I cross twice with a single vertical line. This is not a function. Okay? How about this? Is this a function? Just cross vertical lines, cross this graph with vertical lines as many as you wish until you are convinced. Are you convinced that you can never cross this more than once? Can you cross this more than once? No. So this is a function. This picture belongs to a function with respect to x, depending value is x. Okay? Alright, it is our problem. Function or not? Obviously no, because here we go. How many crossings you make? This time even 3. So it's not a function. Okay? We good? Questions? Alright. Once we know a graph belongs to a function, and graphs come with equations, right? Such as y equal 2x. It has this graph. I don't know if you know or not, but this equation, when you plot it, has this graph. So even this one has an equation. This has an equation like, I can make up one, x squared over 9 y squared over 9 equals 1. And this has an equation like y equals x squared. Pretty much every regular shape has an equation. But this was not a function. This is a function. Is it fair to call them the same title? Like this is x, y equals 1. This is y equals x squared. No. So we kind of honor the ones with being a function. This is an honorable one, or they want a new title. We need to compensate this guy for being a function. We give them a special notation. Instead of representing them as y equals x squared, we delete the y and instead call them f(x). This is how you read it, f(x). Look what they did. They removed y because we know this is a function, right? When you go through vertical lines, you can never cross it more than once. It's a function. Oh, you're a function? Then I won't call you simple y anymore. You are called f(x). This is again just a notation, like a fancy title. Alright? They call you prince, princess, lord, right? That kind of title. We don't call them simple peasant y. We call now from f(x). You are a function. You are honorable. Okay? That kind of thing. I mean, just I'm trying to make it sound familiar. But f is just calling somebody, giving a title. F as in the first letter of function. F comes from the word function. This is not an ordinary equation, it's a function equation, we are just saying, okay? Well, it serves more than this. This notation serves more. Here is what it serves more. With this notation, you can list all couples. You can create and list all couples in that function, because every function actually has couples like this. Look, this is a couple function. It relates a number to another one. It consists of maybe 3 points or millions points, and in an equation you have billions of couples here. You can find whenever which couple you need, you can point them out with this formula. How? For example, they enter 5. I'm wondering what's the couple of 5, and you can enter that 5 into X and get number 10. This is how you couple them. You put 5 to the left, the number you entered into X goes to the left, and the number you entered on the right side and computed all the way, which brings us 10. You pair them up with a parentheses, okay? And if you want to get more, you enter more. Like you're wondering what's the company of 3. We don't know yet. You enter 3 here. You enter 3 on the right side for X. Compute this. Oh, there you go. 3 is matched to 6 with this function. The passenger 3 travels to 6th Street or address 6 by this bus. Okay? So this function notation not only serves a fancy name for that variable y, but also it serves to compute that pair, missing pair, quickly with a simple computation. Okay, here are a couple misconceptions. Most people think when I put f of 3, they think, oh, we need to multiply f by 3. And they take f notation here, 2x, and multiply 2x by 3. They make 6x. Wrong. This doesn't mean multiplication. This means passenger 3 traveling with this bus and going to somewhere. It's a title again. It's a fancy name. 3 travels with f, go find it. You need to literally substitute 3 here and travel with this bus and find it. It's 6, not 6x. So again, it's not a multiplication symbol, f of x is. Again, f is the name of the function, title we gave this function to. Sometimes we go with different names, not f, but G, H, I, J. And sometimes we run out of alphabet letters. We start Greek alphabet like theta, alpha, gamma. In physics, for example, you use different ones like V, velocity. If you're computing velocity of an object, instead of f of x, you use V, letter V. Okay, V as in the velocity. So whatever name is convenient for you, you don't have to go with the function f name. You can use that symbol. Alright? Again, X is the input, or I call them passengers. They will ride in this bus. But to find out where they go, its Y value, you need to enter that passenger name or number into X and compute right side. Such as 5 is going to 10. If you want circle notation, I see that 5 is riding and leaving the bus at 10. So this is the couple you make. This is how you write it. But it needs to be, of course, with other people. Because these two are not the only riders of this bus. Okay? Does the notation make sense? F of x notation? It's just a notation. Don't make it anything more than that. Don't multiply or things. Okay. Here is a quick test, number 4. Somebody let 0 ride in this bus. We don't know the bus formula though. They haven't given us nothing here. It's not 2x, it's not 3x. We don't know what that formula is. We don't know the bus route, but they have told us where this guy dropped off. He left the bus at -1, address -1, -11. I'm sorry, -11. 0 got in and left the bus at -11. All right, what is asked here then? They just want us to pair this up, this result up. So how do you pair it? Yeah, this is just quick check whether you understood the meaning of what entering 0 and comparing this means. 0, -11. That's it. That's all you need to make here. Well, you're gonna do something more in the next one though. This means 0 -11. So you can actually picture this, put a dot on XY coordinates and show this if you want. So it's not just a list, it actually creates a dot. Every time you let somebody ride in this bus, it stains a dot on the picture. If you do this 1,000,000 times, you get a perfect smooth picture of whatever this route of bus is. Alright, the next one, they have given us the bus formula. This is the formula bus acts, and the passenger X rides on it, and it goes to a destination by this formula. What you need to do is figure out where the passenger -2 goes with this formula. So what shall we do? If the passenger is unknown, it goes to this destination with unknowns, okay? But what we have now is not X. What did they do here? They replaced X by -2. How do I compute its destination? What do I do? Yeah, they replaced on the left side. You need to do the same thing on the right side. You need to replace on the right side as well. Okay, so first thing I'm gonna do is empty all the spot with X's. I'm gonna show you some mistakes first. Look, I emptied all spots with X's, correct? Because they are gonna be replaced. So first wipe them off. The second thing I'm gonna do is, don't write this. I'm gonna put -2 here, because that's what's X replaced with, right? And do this. No, this is gonna be fine. 2 squared, -2 squared. Okay, which one are we gonna square here? Are we going to square 2 only, leave out this minus? Or are we gonna square -2 together, negative and 2 together? Which one?
Negatives just become positive, then you just square it too.
Right, we need to square both negative and this together. Alright, here is one mistake people do. People treat this as plus. This is a plus. And then they square 2, this reads as 2 times 2. And they put then the +4 here. This is a mistake. Why? There is a reason I drew this box. This is the location where X was. Now under this location, now there are 2 terms replaced X. Minus and 2 came together. If there are 2 items coming under a exponent, you need to put a parentheses and double both minus and 2. Minus doubles, 2 doubles, and this extra minus is still waiting outside for this to be computed. And when I do these two, it's +4, but minus is waiting again, and multiplies +4 and becomes -4. The result is not +4. It's -4. Why? Because when I square -2, it turned into a positive 4. Negative 2 is coming under the square, and square killing the negative, but that square cannot kill this outside negative. This is outside the square, this negative, so it can't change this thing. No, it can't. Alright, how about the next one? Again, use a parenthesis for caution. Be cautious and use always parentheses if there is a negative number inserted in x. What is negative 2 times negative 2? This thing is positive 4. And we have a 2 coming up afterwards. Now you add all three together. Positive 4, positive 2, and negative 4 in front. Positive and negative 4 cancels. And the result is 2. Okay? Any questions? Alright, we're doing this again. In number 7, something weird is happening. What is our passenger this time? It's not just negative 2 or negative 1 or 5. It's a weird symbol. Do you guys know what this symbol stands for? Pi. It's pronounced as pi. It's a never-ending number. Starts with 3.14, 1/5, etc., etc. It's a never-ending digit. Always new digit shows up. So, shall we enter here in your calculators 3.1415 this everywhere? No, because you don't have enough space in your calculators to type in millions of digits, because it's a never-ending number. So what shall we do then? If you don't know that number for sure, that's why they call this symbol though, because they were sick and tired of listing millions of digits. They couldn't list it, so they called it a short name. Pi is the name of this weird number. That's why they picked this number. Go with that option, pi. Put it here. If x turns to pi, you need to change every x on the right side into pi. This time, you don't need a parenthesis around pi, because it's already positive single notation. It's not two terms like minus and 2. This is single. Everywhere you see x, make it pi. Okay. Next, are we going to again enter here 314 and square and triple it? 314 minus 2? No. Anytime you take 314, you're cutting off digits. And they say, don't cut off digits. Leave it as whole answers. Because when you cut off, you're rounding off. We don't not need approximate answers. See if you can cancel anything, simplify anything with the current situation. If this was 3 pi and 2 pi, I could cancel this. But these are not like anymore. This is pi square and single pi. They won't combine. I can't cancel 2 pi and 6 neither. So this is my final result. You just make x is pi and you're done. A basic substitution. That's it. So how do we type this in? By the way, we skipped number 6, which is 7. Number 6 is pretty similar to 5. You just type this in with the pi symbols. Pi from the toolbox. Squared. Go down. Minus 2. Pi. Minus 6. All that. Okay. What if the question was not g of pi, but g of this? What is this? What is this? Come on, my drawing is not that bad. This looks like something. Maybe the tail missing? It's a turkey. Yes. So if even you see turkey here, you just need to make turkeys in every X. That's the idea. Okay? Yeah, if the turkey turns into number, yeah, you're gonna make these numbers. 1, then you put 1 there. That's the basic idea. Switch X by whatever shape or object or number you see here. Replacement, that's it. Don't try to multiply pi with this whole thing or something, no. Okay, that's idea here we use is gonna work here great. Look. They want us to compute, unfortunately, not 7, not just S, not just pi, not just turkey, it's S minus 7. How do I do this? Again, what's given is this, k of x, absolute value of x plus 4 given, with axis. They want us to compute S minus 7. Alright, here is one idea that comes to my mind quickly. Intuitively, I feel this comes natural, right, to my mind. This is x, this is s. First thing I'm gonna do is I'm gonna make every x into s. I see s, I'm making x to s. Oh, they subtracted 7 from s? Then I will subtract 7 from the n. This is what comes to my mind. Is it correct though? This is a violation of turkey rule. What did I tell you? If you see something else other than x here, even you're a turkey, you're gonna make that particular x turn into turkey. So what is your turkey here? This is the turkey here. All you need to do is wipe off x and make this turkey right here. Don't invent new things. Oh, this is xs and I subtract 7. No. Wrong. This is wrong. All you need to do is repeat top expression, top, without x, empty out its spot, because it's gone, it's history. X is no longer visible in parentheses. It's gone. X is gone. What comes in place then? Whatever you see between these two parentheses, even a turkey shows up, you put turkey here, but it's not turkey. This time it's S minus 7. That's your turkey. Okay? Alright, are we done now? Almost. This is what you have, S minus 7 plus 4. Just simplify as much as you can. I see two like terms here, 7 and 4, negative 7 and 4. We can combine them, right? They become S and, what is negative 7 plus 4? 3. Okay, here comes the $1 million move. I know absolute value makes negative things positive. Can I make this, S is already positive, this negative 3 into positive 3? Can I? No. Don't do that. Don't. Because first off, we don't, how can you take S out like that? Do you know S is positive? What if S is minus 2? How do you know S is not minus 2? Then you're making here minus 2. How come absolute value let a negative number out? S can be negative maybe. So if you have a variable inside, that variable can never leave an absolute value. This guy is stuck. Oh, okay, I'm fine with S being stuck, but can I still move negative 3 as positive 3? Because we know negative 3, right? It's a number, negative number. Can we still make it out? No, we cannot still, because S and 3 is a block. Just like in cancellations, can we cancel S and 3 separately? No. They are linked to each other with a minus. They are glued with a minus and are not separable. You can only separate minus 3 if it's a product. Look, this is a multiplication. Then you can leave this as positive 3. Absolute value is okay with multiplication, but not subtraction of minus 3. Okay? So watch out for that. So you don't have to do anything else here. This is the final answer. S minus 3 can never leave, can never change into anything else. That was just small detail, but did you get the previous parts? Just switch x by whatever you see underneath parentheses. That's S minus 7. We're all done. Okay. So how do we type this in? You know how to make absolute value, right? There should be a toolbox button for that. Here you go. This is absolute value. No, it's such that. Oh, this is the absolute value. It's not that one, sorry. Here is the absolute value. And the answer was S minus 3. Any questions? Basic substitution, that's it. Alright, we're doing just comprehensive questions next. How do you read couples? Now this is a function picture. There are just billions of dots on it. Can you see each and every one of them? There are billions of dots. Every 2 dots has another dot between them. You can make these dots really tiny a little bit, but when you take a magnifying glass and look at it, you will see always a point between 2 points. There are billions of dots here, but each dot has an x and y coordinates, such as this one is 1, 2, 3, 4, like minus 3.5 and 4.75. Who knows? Okay, seems like so. So every dot has an x coordinate, y coordinate in decimals or whole numbers. Question is, how does this help us figure out function values evaluated at specified x values, such as how do you find k of minus 2? That's what I'm going to show next, okay? How many of you guys know how to do this? Raise hand. Alright. Here is this minus 2. The number minus 2 is your for passenger. Passenger minus 2 rides on this bus. But x is the list of all passengers. So they are actually providing you x value. So you need to spot this x value wherever x is marked. So you're going to find that x value on this axis. Where is minus 2? Negative numbers are on the left. You go 2 spots to the left and mark it. Again, this is your passenger waiting for the bus. Now he sees the bus and goes towards it. And this is the bus formula. And hits the bus. And you're going to make the contact value. So you go up or down, hit the bus, and make contact with the bus. Okay? And the bus is going to take this guy into an address. This is the address list. Wherever this guy lives, he's going to drop it off there. So to see which address this guy moves, you need to always go towards, once you make the green dot, go towards y-axis directly and read that value. What is this value? 3. This is it. You just found it. You actually coupled these, minus 2 and 3. You're actually reading the coordinates at this point. Minus 2 is where everything started and created this point. And then 3 is found by going towards y-axis. So you created a couple. The final answer they're asking is what is the destination is going. It's 3 only. But the number here is couple is minus 2, 3. Alright, this is number 10. Number 9 is very similar. So once we do number 10, you can do number 9. I picked the harder one. 10 is a little bit harder. And k of minus 2 is 3. Alright, second part, k of 4. Pretty much same work. You first find passenger, this is passenger list. Where passenger 4 is. Go 4 unit right, 1, 2, 3, 4. And this passenger 4 runs towards the bus. Where is the bus? Bus is on the top right here, right? You don't go down. It's not nothing underneath. So you go up. Wait a second. I go up and up. I never hit the bus. I never meet the bus. Do I really not meet it? What is this point? Are we hitting the bus or not? Are we skipping the bus? Which one? What's the situation here? Do we hit the bus or miss the bus? We are missing it. Why? Because there is a circle, open circle here. Open, empty dot. That means it's a hole. You missed it. If you don't hit the bus, you can't go. If you don't meet the bus, you can't go to your destination. So what's the word, the conclusion here then? It's called undefined. They didn't define. We don't know where 4 goes. 4, we call 4, this is another statement, another way to say it. 4 is not on the domain of the function. Domain is the set of all passengers. 4 is not on the passengers list. 4 is in actually no fly list. The bus driver didn't let him ride it. Okay? So what do you choose here? There's bottom for this, undefined. That's what you go with. Okay? Next passenger, minus 1. Where is minus 1? Here is minus 1. Go hit the bus. Alright, this is the contact. You're riding on the bus, and where do you go? You just need to read y coordinate of this point, which is 2. Okay? Alright, now we're doing things backwards. For what passengers? X is our passengers again, right? There is a mysterious guy who rides on this bus, or guys, maybe more, because it's plural, you see, S, passengers. What passengers? Who lives in address 1 or city 1? There are some people riding in this bus and going to address 1. Who are they? Anyone? So where is the address list? This is your address list. We are looking for 1. This is address. Here is 1. No, I'm gonna make a notch instead of a dot. Here is 1. Who goes to this address with this bus? 0. I see that right. This guy, 0, once he rides the bus, this is the contact he makes, and the coordinates of this point is 0, 1. I'm sorry, it's 0, 1. So it's going right on that spot. You're already on the address. You're not going right or left. So x equals 0. You think that's the only solution? Oops. No, we are wrong. There are 2 separate guys living in the same address. You only spotted 1. Who did we miss? What? 3. There is another guy here. Look at 3. He rides the bus. Guess where he gets out of the bus? Look, when you make the contact, go to the left. He lives in the same address 0, 1 or 1, y equal 1 as same with 0. 0 and 4 are two solutions. There are two people living in a... So how can we make these questions correct? If they have given y value and asking for x, take a color pen and draw a horizontal line at that level, at 1, and see how many contacts do you make. 1 here, 2 here. That means there are two separate x values, passengers going to the same level. Okay? Then read those values, 0 and 3. No, 0 and 3. Yes, this is 3. Sorry. Let's mark them. 0 and 3 are the guys going to that address. Alright. Who lives in address 0? Who? I'm going to take this line back to 0 level. This is 0 here. Address 0 is here. Who lives in address 0? 1 and 2. I see one contact here, one contact there. It makes sense to me. 1 and 2. Is that really 2 points going into 0 here? Do you only have 2 contacts within green and blue curves, lines? It's not just 1 and 2. It's 1.5 as well. It's 1.3, 1.9, 1.7, 1.99, 1.79. How long can we do this? Everybody between 1 and 2. Start with 1 and 2. Take this piece of line segment. If you have a line segment, you cannot list the number of terms in there one by one. You cannot list it as 1 and 2. So how do we represent line segments? How do you write them up? What do you mean by infinite? Like this? There are infinite numbers, but how do we represent all of them once in the answer box? For example, there are, you mean the solutions here are infinitely many, but in the next step I think they are going to ask for it. What are they? They're going to say, yes, they are going to say all those values making 0, we are going to need to represent them in interval notation. Again, in this course, in any future course, if your solutions are infinitely many points on a piece of line segment like this marked, you need to always represent them in interval notation. Either this, one side closed, one side open, one side open, one side closed. So which one are we going to use here? If you see the endpoints are giving 0 value, you do not need to include them, and we do have endpoints included, right? So we go with a bracket and put 1 and 2 here. Okay? Alright. Now we are going to talk about domain. I need to clean this up. It's gonna take a while. Clean this one up as well. Alright, here is what domain is in real life terms. Buses are our functions. Domain is the set of all x values. In other words, set of all passengers. This is x values or passengers. everybody riding in this bus is called in the domain. It's like fly list. Your bus has people, name of people got the ticket. That list is called domain. For example, is 4 on the domain or not? Is 4 on the domain? Is 3 on the domain? Is 2 on the domain? Are they traveling to somewhere with this bus? Yes, except one guy. One guy is not on the domain so far. Who? Who's not on the domain? Who? One of these guys is not traveling with this bus.
4.
4. Because you're skipping the value. Look, you're not hitting it here. You're shooting up, but you're missing the target. But 3 travels this bus to 1. 2 travels with this bus to 0. Everybody is fine until -4. How about 5? Is 5 good? Or -4.3? Is -4.3 on the domain? No, we miss it. It's cut off here. So the way we found domain is like Friday. You need to step on this curve, compress it. We use this, right, with metal plates. You compress it from both sides. See what falls onto x-axis. Compress from top and bottom and see what the stain is. Like this ball or point is gonna fall to here. This one is gonna fall here, but everything in between is gonna fill up this space. It will keep going like this. What is the cutoff? Is there a point filled in here that's gonna fall to ground? No. This value is gonna be skipped. So everything from this end, what is the end value here? 1, 2, 3, 4. -4. Everybody starting at -4. I'm gonna put a bracket here, included -4, but not included this end. 1, 2, 3, 4. I'm using parentheses here. -4 to +4, except +4. Everybody in between is in the domain. So how do you write this? Bracket -4, comma 4, parentheses, meaning 4 excluded, because there is a hole in it. Range is the last thing we're gonna do. Range is the list of addresses these passengers travel to. In other words, range is the Y values corresponding to these blue dots, millions and billions blue dots. So for finding range, we do opposite side. We compress from left and right with metal plates and smash this picture into y-axis and look up the image. So from the bottom, I see nothing falling from this side, nothing. Skip, empty, 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 empty until this moment. There are billions of dots falling to this level. There is a couple of dots falling here. And there is a couple falling here. And when I come to this moment, I'm going to put a hole here because there is nothing falling from this side, right? And then I have points falling and keep repeating. Am I doing it right? So this is my image. It goes up to as high as here. This is the cutoff. This is the end. Start, take a break, end. So it's gonna be union of 2 pieces. Am I right? Where is mistake?
What's the line on the 2 that cuts right there, fill in that spot?
Yeah. Although we skipped this value, this one is going to make up for it. This point is gonna fall when you smash from this, and this point is gonna come here and fill it up, because the left side is saving us, although the right side is missed. So there is somebody leaving the bus at stop 2. This is stop 2. Who's leaving the bus there? Passenger -1 takes this bus and goes there. So it's filled in. Everybody from 0 to 4 is fine. So we shall enter 4 and 0, both ends included, right? Am I right? This is what you did on Friday in the quiz. Wrong. Why? Yeah, we need to always read any kind of image on y-axis from bottom to top. 0 first, top 4 is next. Small number first always.
Could be a parenthesis as well next to a 0.
Alright, are we gonna use a parenthesis? Good question. At 0. That means if you use a parenthesis, you're saying that nobody goes to 0 address, nobody writes to 0. But there are people, these people are going to 0 address, right? Look at the coordinates of this one, for example. This is 1, 0. This is 2, 0. 2 is traveling to 0, right? So 0 is included. It should be bracket, not parentheses. Okay? If this was a little bit above, yeah, it's not touching x-axis, yeah, we could say 0 is excluded, but no, we're good here. Okay? No, what's wrong? Oh, it's not 4. The end is 5, right? This value is 5. Okay, we're good. We'll continue this section tomorrow. We have a couple more questions left.